Welcome to the Meltzone podcast. This is episode 37 from August 14th, 2020. I'm Tom.
And I'm Stefan. And I just became a father.
Yay!
Yay! We're not only going to do father talk on this podcast episode, maybe just a little, but I'm still looking, I think, quite healthy for the moment and still get a bit of sleep. So yeah, on other topics, short, just talking about 3D scanning and Tom's latest video and some cool 3D scanning sublimation sprays and stuff like that. Then again, 3D printed food, KFC 3D printing chicken nuggets. Is that something we should look forward to? So let's see. Two kind of bike topics. Superstrata is showing off their first custom 3D printed unibody carbon bike, which is really cool. And then the ramble starts, and we just have a quick talk about Big Rep's fully 3D printed motorcycle and if it's really fully 3D printed. So yeah, stay tuned for that.
Then, in more news, there is now a 3D printed gunpowder called quote unquote substitute. We talk about like how that could be used, that 3D printed approach could be used in more propellant applications. There is now an open norm for open hardware. Aside from the already existing Open Source Hardware Association definition, there's now an official German DIN norm, as we have for everything for open hardware as well. And staying on the topic of open source, Dr. Joshua Pierce now has an open source computer vision approach that can do something similar to what the spaghetti detective is. We look into that. 3D printed houses. That's where we get into the rants. There's been a new 3D printing housing company that's made an announcement about, we're now cheaper, we're now better, we're now faster. And the biggest rant of them all, Kickstarter 3D printers and Kickstarter 3D products in general. Why don't do them? Why Stefan has been cautious with them as well. And yeah, we don't want to do too much ranting. So we also answer a question about printing exotic materials and ordering them from Shapeways. Stefan, you look awake, refreshed, holding up. How is it being one extra person now? Tell me.
It is different. It is different, but it's also nice, to be totally honest. I can be really happy at the moment that I still get quite a lot of sleep, even though I still feel a bit exaggerated. No, not exaggerated. Exhausted, that's the right word. But so far, so good. Our daughter is kind of, just wanting to drink once a night, and my wife's taking care of that, and I have a really good sleep, so I just basically sleep through all the night. But it is different, and it will be different.
Yeah, so obviously for those of you not in the know, Stefan just became a dad a week or two ago, and so living with a newborn. Again, I think you've taken it pretty well, and like I've always said, I think you're going to be a great dad. Congrats to the new family edition, all that. Ah, nice.
You would not actually imagine what kind of sounds a baby can do just when it's lying around, from squeaking noises to coughing noises to whatever. And if it's the first time for you, you not always really know what to do with it. So it's an interesting experience.
I mean, my closest experience to being a dad is when my half-sister was born. So I was 14 at the time. So I basically got to be the, somewhere between a young uncle and an older brother. I mean, being 14 years older, I'm more on the adult side than on the bro side, I guess. But I did get to experience the baby thing, not as a hey you have to be there, but as like you can be there. It's it's gonna be interesting.
Yeah, it's
sure.
gonna be interesting.
You're gonna have lots to laugh and
and lots to cry.
Sure, but
the most interesting and That's probably exaggerated, but one of the things I am really curious about is how it affects my work, because previously I think I had still a lot of spare time that I used for all of that 3D printing stuff. Currently, I'm still on parental leave for another 6 weeks or something like that. So still plenty of, I guess, free time. But when normal work is starting back up again, I really need to figure out how to delegate work, how to produce videos faster, and just to get everything more streamlined.
Time management.
Really, I'm horrible.
So am I. Set aside time for. I mean, who am I to give tips on time management? Yeah, set aside time slots for. Okay, these 2 hours I'm going to be working on that, and that. Please do not disturb that entire thing.
Maybe it's finally the chance to at least get a bit over my procrastination habit, and just to notice, okay, you need to work now, otherwise that work's not going to be finished.
You just talked about, borrowing a PS4 and playing Ghost of Tsushima. So what else are you planning to fit into your 24-hour day? Are you just skipping sleep?
No, I'm really bad in sleep deprivation. Well, playing video games from time to time is just something for me to relax, and I still need to do that in some way, I hope. And as I said, since I'm still having 6 weeks of parental leave, I hope that I find the time to get through Ghost of Tsushima. I don't really know how it's called.
Sorry, anyone who is a native Japanese speaker. We're butchering everything, but
we'll see.
We're trying.
Yeah, we'll see. Time management is probably going to get really, really interesting, but we'll see.
The real question, though, is: have you 3D printed anything for your daughter or the baby yet?
Well, I think not directly for the baby, but we have one of these like wooden baby chairs, and we had a used one, which I kind of renovated, and the feet that it had below it, which are like specially formed for sliding stuff on and off of it. I actually 3D printed those, but otherwise, no, not yet. No, not yet. Choking hazard, still scared. I don't know.
True.
At some point, I guess.
Yeah. And while you're busy producing poop, I'm also producing my own poop. So by the time this podcast is going live, this will have released as well. So yeah, one of my babies, the Mark III's made some poop finally. Polycarbonate blend, Prushament, really nice material, but if you print it in an open space, it's gonna peel. Like if you try to, I don't have the original part here, but if you try to print like a full-sized, covering the entire bit, I'm surprised that it worked, but it just peeled off. And I think one of my first hot-end encasements that I ever got.
Okay.
Yeah, I think so far prints have always stuck down, or I've been there and was able to intervene early enough. But yeah, you can see the hole where the hot-end was in. But you just heat it up, you pull it off, and it's fine.
You are not regularly using silicone socks on your hot ends, especially the 3D ones. No. Yeah, those are the killer. And this was the reason why I designed my own at some point, because if they they get grabbed by the print, they are just slid down a little bit from like the nozzle, and then all of the material just goes in between the space of the silicone sock and the hot end,
and it just gets redirected up.
Exactly.
Yeah, thankfully this was all down. Like you can see, it's like barely going up the side of the heater block. So I 3D scanned this. And I really don't know what my intention was with that video. I threw it into Blender, made let me show you.
Made a low poly version.
It's not the classic low poly where it's just every triangle is the same size roughly. It is in Blender the angle mode. So it's like It looks really cool when it's rendered. When it's printed, it just looks like garbage, honestly. So I already had shot the whole process, so I still made a video out of it. But I don't know. Is this art?
It looks really cool, especially in the what's the color of the filament called?
That's the Mystic Green.
Mystic Green, Prushaman Mystic Green. Yeah, it has a really nice shine.
So yeah.
Yeah.
And it's the original has a lot of interesting texture. That's just why I thought I needed to do something with it. I don't know. It's poop. I've also uploaded that to Prusa printers. So if somebody else wants to do anything with this,
cool.
I don't know. But yeah, got to try the. Do you have any of the stuff? The ASUB scanning spray.
I
was it going to send you some?
No. I know of it, but I have never used it so far. I think at my company, we finally purchased some because it's, if you have like intrigue parts, it's easier to clean them off with that stuff because it just sublimates away.
Yeah.
But I have never used it. Are you happy with it? It's not that expensive though.
They accidentally sent me like a dozen cans.
Okay.
So I don't know how much it is, but it's actually really cool. It smells like solvents, and if you look at the MSDS, there is like this stuff is like 60% solvents.
Okay.
But it does create a really nice, thin, fine foam essentially on your part.
Okay.
And you can wipe it off with your fingers, but after a few hours, it just disappears. And this part, I've not cleaned it off. It feels like there's never been anything on it.
Okay. But if you're
really happy, and it's
But if you're saying it creates a foam layer on top, one of the things that I would be scared of if I use 3D scanning, not just for reproducing the part, but to do real measurements, do you think it adds a lot of like thickness to the part?
It does add thickness for sure, but I don't think it is a lot because first of all, you're not putting a lot of material on.
Okay.
And there is a lot of really fine detail in here that the scanner didn't pick up. That's just because the scanner isn't, good enough for that. But just visually, it was really hard to tell that there is a thickish layer on it.
Cool.
So, yeah, if you have it at work, give it a try. It does not work for photogrammetry. Obviously, because it creates a really even layer. Yeah. But for the structured light shining 3D scanner, it's pretty cool, pretty perfect.
You still have the shining 3D scanner. Do they actually upgrade or update the software from time to time? Because that has been a mess in the beginning.
So they have, I think like literally 3 days ago, they have released the 3.0.0 software version.
Okay.
From me using it, it looks like it's really just a new skin on the old algorithms, but it is updated. There are a few new measurement features in there.
Okay.
But yeah, it is still supported by the newest, greatest, whatever scanner suite there is specifically for the SE and SP. So both really similar products. Both have the projector and the stereo cameras, but the SP has like twice the resolution and a larger scanning volume.
Okay.
So yeah, it's still seeing updates, which I'm surprised it is.
Okay. It has been around for a while. It's around $1,000 or something like that.
I think the SE is a bit less, and the SP is like 1,500. Don't quote me.
Okay.
Yeah, something like that. Still cool to bring out, and I still need to give it a try on the tripod scanning mode because right now I'm just doing it with the turntable that's like auto progressing the scan.
Yeah.
But it's always nice to see because you can just plop it down onto the turntable. It does the revolution, and then you reposition it any way you want. You do it again, and it auto matches those scans, so you get really good coverage.
Yeah. So
it's pretty nice.
Just one tip on the side, if you are also looking into like, doing comparison and measurements and stuff like that, GOM Inspect, which is available for free, is just, you can do anything with it. Great tool, kind of easy to use, and you can do anything with it. Considering
I still need to try it out.
Measuring and stuff like that. Just if you ever feel the need for doing something in that direction.
Yeah. It has been recommended to me from various people. Maybe time to try it out. Yeah. yeah, that was just what do you do with those projects that you invest time in and it's like I don't really know where this is heading. Like this stuff, I've got a really cool render sequence in the video, which is the full cycles rendered Blender ray tracing thing. It took like 6 hours to render. It looks really cool on paper, but in practice, once you print it, it's like, what the hell is this?
Yeah.
What do you do with that? Like I guess I sold it as like, hey, it's a nice experiment to do. To learn more about scanning, to draw out the sprays and that, but it's like it looked cool at the onset, but just didn't turn out. What do you do with that?
I think you did it exactly right. You there's so much stupid stuff on YouTube, and at least doing it the way I think you did it adds a bit of like mechanical engineering background, or just doing it a little bit smarter. So it adds value to the process, but it might be entertaining for some that don't like other stuff. And still in the end, you learn something, and I don't know. We'll see if people will like it or not.
Yeah, I'm really interested in how the video is going to perform because it is shot like a vlog, more or less. There's no scripting; it's just on the fly, and a few different camera angles, a few different setups. We shall see.
Yeah.
We shall see.
Definitely.
Should we jump into a few topics?
Of course. More 3D printed food. Chicken nuggets.
Chicken nuggets. Chicken nuggets. 3D printed food, yeah. KFC.
3D printing or wanting to 3D print chicken nuggets in Russia. Today I kind of prepared myself and I read through all of the articles that we have on the show in the show notes. And so I think what KFC actually wants to do, they are, I think, not only just grinding down chicken and then extruding it into interesting shapes. What they want to do is grow meat protein or meat, I don't know, tissue particles in the lab, and then mixing that with, what did they say? Let's just say fillers, and extruding that.
I guess it's going to be a hybrid between lab grown meat, which sounds disgusting, but it's actually I don't think it's less disgusting than actually farmed meat.
Yeah.
So a mixer of lab-grown meat and something that like Impossible Foods are doing with it, which is a plant-based, made-to-taste, feel, and look like an actual meat product. And I think that is actually the bigger part of that announcement. The 3D printing is just, hey, buzzword 3D printing lab meat doesn't sound that cool, so let's do 3D printed. But yeah, it is lab meat combined with a plant-based meat alternative that is then shaped, I guess, into something that looks like traditional chicken nuggets through a 3D printing process.
So 3D printing in that connection for me is really just a buzzword because, well, if you know how normal chicken nuggets are made, those are also like extrusion products. You grind down the meat, add like salt and some herbs and stuff like that, and then just extrude it out, cut it into pieces, and you're done with your chicken nuggets. Why 3D print them?
Pink slime, right? That's the buzzword there.
Yeah, the pink slime, but I think
least
that's
in the US.
Yeah, that's I think a bit of an exaggeration, and they're probably not like cutting the fibers down that much, but it's still a real slurry in the end. And
if you look at it's used in the EU, I think, as well. If you look at any like chicken-based meat product, like meatballs or stuff, if you have fein zerkleinert,
yes,
that is non-meat chicken parts, as far as I understand it, that are just like the what's it called, knoppel, or other non-meat fibers that are used from the chicken. I mean, anyways, so this is basically a continuation of what we talked about last time. All the different ways of producing 3D printer and non-animal meat.
Yeah.
Yeah, I guess that describes it pretty well.
No, it's
now it's KFC that's in the game. To see.
Really, really interesting to see, and I'm quite excited to see when we actually get the opportunity to try the first lab-grown meat at some point. But I think this might be an interesting solution because you basically won't be able to like grow half a cow in the lab. You probably will be able to.
Never say never.
Well, at some point. For the next years, we might only be able to produce like small muscle fibers and stuff like that. And
sure,
instead of trying to form that into a steak, why not produce chicken nuggets out of it? Might have the same taste.
Ground meats are already the thing that can be reproduced pretty easily. Yeah. I guess what's popping up in my head right now is it actually going to be labeled any different? Will we be able to tell the difference between the highly processed, I guess, KFC? Well, I guess if you have drumsticks in a bucket, that yes. But if you have chicken nuggets, would you, as a customer, because they're already that they're fried, they're spiced, they have the panade around them, the batter around them, whatever, you wouldn't really be able to identify that as a piece of meat versus a piece of lab-grown plant fiber mixed meat. Are you just going to throw them in with the regular stuff and be like, hey, yeah, we've got a new recipe?
Yeah, probably. Well, currently you can already hardly distinguish between like the vegetable-based or non-meat alternative chicken-like nuggets to normal chicken nuggets. So yeah, I think it's going to be just more of the same. The real challenge will be a lab-grown steak.
I guess, yeah. Yeah, but before we turn this into oh god, the next topic isn't any better. Before we turn this into a vegan podcast, let's talk about road biking, because that's not a topic that people get riled up about. damn bikers, damn cyclists. Superstrata have the quote world's first custom 3D printed unibody carbon fiber bike. That seems oddly specific
because I think because 3D printed non-unibody bikes have been already around. I think there's a Swedish or Finnish company that produces kind of the joints of the bike with a metal 3D printer and puts carbon pipes or tubes just in between. Color Fab actually did a 3D printed bike with their carbon fiber material years ago, and they did it kind of with the same method. They printed the joints and then joined up those parts with carbon rods. But the thing that Superstrata is doing is they are printing the whole frame as one kind of continuous body, which is really interesting to see how they are doing it and how they're handling the supports and stuff like that.
The thing about carbon fiber parts, especially when it's like low volume, like bikes and stuff, is that it's still an incredibly manual process. Like, you have to manually handle all the carbon fiber cutouts, all the molding, just if you want to look at really low volume production, you can have a look at Easy Composites. They show the one off or maybe a dozen part small series process really well. They've got a bunch of tutorials on YouTube. But yeah, even with bike frames, it is still an incredibly labor-intensive process, which is why they commonly, or almost all of them, are made in China or in other places where labor is a lot cheaper than it is here. Mm-hmm. So that's really going to be an interesting thing if 3D printing is not just a customization part, but actually a cost down driver, a cost reduction measure in that case.
Indeed. Well, I have skimmed over the article. Have there been any details what kind of material they're using? Are they just using like carbon? shortcut carbon fiber filled materials? Are they using any continuous carbon fibers?
They are using a continuous carbon fiber thermoplastic composite.
Okay.
So I guess it's kind of similar to what Markforged is doing with their carbon printers.
Yeah. And desktop metal. And anisoprint. Yes.
Yeah.
So
yes. Well, Markforged were the first ones, right?
I think they were.
Yeah.
So they're basically putting, out of the nozzle, there's basically coming a strand of polymer which has a carbon fiber in the middle, and the carbon fibers is reinforcing the plastic. And that is a good thing, especially for a bike frame, because it will see quite substantial loads. And the goal for such a frame is that you are not that much heavier than a conventionally manufactured carbon fiber frame.
The question is just because they're using a thermoplastic, like, can you actually ride it out in the heat, or if you brake hard, is the frame just going to squish to the if you're out in the sun?
I asked that question to myself as well. Well, they are saying it's a good thing that they're using thermoplastics because that makes their bikes recyclable, even though I don't really understand how you can separate the thermoplastic from the carbon fibers later on.
You shred it down and you sell it as a carbon fiber 3D printing filament.
Oh, yes. That's a good idea.
Right?
Yeah.
No, because anything else that is carbon fiber that is done with a resin needs to be downcycled. So it's getting chopped down and then, sometimes just even used as concrete fill, essentially. Or, best case, you have like nice large chops that you can then use with more resin and put it into or shape it into a lower grade of carbon fiber composite.
Yeah. So this is something, but definitely, even if they are using nylon or something like that, I wouldn't be. Well, the question is, there are lots of also thermoplastic parts already been used on a bike, glass fiber filled or glass bead filled,
sure,
PA. So why not also the frame? Probably because it is carrying more load, because it needs to be safer than just like the holder that your smartphone is.
I think it's about. I think it's about size, just simply because it is harder to manufacture those parts at a large scale.
Yeah.
Like if you just have a brake lever, let's say, those are very commonly just a carbon, not an oriented carbon fiber, but just a carbon reinforced plastic. Really easy. Forks. Road bike forks. I've got a Canyon road bike. I wouldn't call it a race bike. It's just fitness bike. Carbon fiber fork. It doesn't look like carbon fiber. It's for carbon fiber. It doesn't look like carbon fiber. It's just, I think, a really simple chopped carbon fiber fork that's been molded somehow.
Seriously,
probably super cheap to make.
Okay.
And I think that's one of the parts where it's like slowly scaling up. So those simple carbon fiber forks are just the new norm now, because they can now be made after small bits like brake levers and stuff, or handlebars became the norm, being made out of carbon fiber.
Yeah. So the interesting thing with 3D printing bike frames is that you can customize them to the customer's needs, because everyone has like a different body geometry, and you can directly adjust the geometry on how somebody is looking and how somebody wants his bike to feel, which is just in a limited amount possible with conventional manufacturing methods.
Well, you can get handmade bike frames if you've got the cash for it. But typically not carbon fiber.
Because making, you need a mold and everything and stuff like that. So that's probably really expensive. And this is also one of the things where they said, okay, their method, at least if you're doing smaller numbers, is cheaper in terms of what you need to invest, because you need just more or less the printer, and then you can print any bike frame on it, instead of having to machine a mold for each bike frame size where you laminate your carbon fibers into. So, and I think, well, what they're also able to do is orient the fibers in a way that they are optimal for the loads, maybe saving weight. I don't know if that always really works, especially because you're still having kind of a layer by layer process if you're doing FDM 3D printing. Yeah. So you do not have the possibility to be totally free in terms of fiber orientation. But, well, taking a look at a bike frame, most of the loads are, well, I don't know, bending loads or axial loads, actually. There will be some torsion. Torsion is probably not taken that well by just uniaxial strands, but
yeah,
don't know. Would probably need to
need more details. Yeah. Unfortunately, they are from California, so that's not something that we could just hop over and have a look at. But maybe one day.
Maybe they're gonna be at the Eurobike in Friedrichshafen at some point. I don't know if that's happening this year.
We shall see. Okay, but staying on the topic of 3D printed bike frames, this was a bit of a rant that I had to get off my chest. Big Rep, venture capital founded or pushed a company from Germany that are building big printers. They've got like the 1 cubic meter printer, now even bigger ones. Again, posted about their world's first fully 3D printed e-bike. So, congratulations to Big Rep for printing, a fully 3D printed e-bike. Except that it's not fully 3D printed. And I don't know if it's the world's first, but it looks really cool. It has a lot of like stark shapes and geometric patterns on there. But yeah, they've printed the wheels, which is nice. They've printed the frame, cockpit as well, handlebar, all of that, seats. But the actual e-bike part is just off the shelf components, basically. So of course they didn't print any of the mechanicals. They didn't print bearings. They didn't print axles. They didn't print the motor, the batteries, control electronics. Does this thing even have brakes? No, I think it's just an electric brake.
Have you actually seen it at Formnext?
I think I've
because I think I've already seen it for the last 2 years at Formnext in some form or another. And it looks quite interesting. I don't know if it makes any sense, but yeah, calling it fully 3D printed is probably a bit too much. But yeah, I would really be interested to see how 3D printed tires perform, and if they printed it from like 2 different materials, or if they're just ABS wheels all around and totally.
So they're saying they're using their own Pro Flex, which I guess is the flexible material they're using for the tire treads. Pro HT, so probably a high temp PLA or something. Mm-hmm. Using PLA, just plain old PLA, and PTG.
Okay.
So I guess this is a machine that you should definitely not use out in the sun. They're saying they're using the HT for rigid parts, PLA for color details, and PTG for the light reflectors.
Interesting.
Tires, bumps, seats, and handles are printed with flexible material. So, yeah. I don't know, guys. I do like seeing big new things where it's like world's first 3D printed e-bike. If that was accurate, I would cherish the idea. Yes, but please, like, who's gonna read it and be like, who's not gonna second take that?
Yeah,
please be realistic with your claims.
Marketing.
Anyways, I don't want to rant too much about it because there's so much more in that direction that he could rant about, but yes.
Let's rather talk about 3D printed gunpowder.
Oh yeah, that's a much better topic.
So let me open the article.
I guess at the outset, this is we are still not talking about Star Trek Replicator, where you say, "Hey, 3D printer, here's some film, and please print me some gunpowder out of this." That's not how 3D printing works. Same thing with 3D printed food. Is 3D printing is just a reshaping process. So you're not 3D printing gunpowder, you are reshaping your existing materials into something that makes gunpowder more or perform better.
Yeah. But the interesting thing is those are so some Chinese researchers, they 3D printed gunpowder, and I think the first challenge was they have been using an SLA printer to develop a resin that, when it cured out, kind of combusts, similar to, like a gun propellant. The interesting thing is that they're not just like printing pellets of material, but they're trying to form the charge in a way that it burns more efficiently and maybe more predictable and maybe more customizable to kind of fit it to the need that they have. And that is kind of interesting. If you usually have a charge, I think it's just like granulated, gunpowder, and then the fire starts at one end and progresses through the material, and you don't have a lot of possibility to change how the powder burns, besides the composition of the powder itself and maybe the grain size and stuff like that.
Yeah. So what they've actually printed is a honeycomb-looking structure, essentially, that then gets filled with, if I understand this correctly, with RDX, which is an explosive. And if I understand this correctly, the printed part actually partakes in the combustion process. So it's not just a geometric shaping part, but it's actually something that burns alongside your explosive and modifies the way the way the combustion happens. So that, I mean, what exactly is this going to be used for? I don't know. I guess for creating new types of explosives. I guess gunpowder or charges for ammunition is just one use case. Commercial detonation, demolition, that sort of stuff, of course, is also probably going to profit from this. But obviously, firearms, big and small, are one of the use cases they're showing off here. If we take this a step outside the obviously destructive nature of gunpowder printing, what I find interesting is that this is really an attempt of creating a metamaterial out of a 3D printed structure. So the shape and the way that these two materials, the RDX and the 3D printed part, are mixed really define the way how they perform and what they do. So that's, for example, something we've already seen with gyroid infill, where the shape of your infill really determines how it mechanically performs. And I think with the amount of resolution and detail reproduction of an SLA printer, that has a lot of potential.
One of the projects I also wanted to try for a long time. Do you remember the salami rocket from the Mythbusters? So I think I do. A hybrid rocket where just any combustible material is burned with the help of nitrous oxide.
Okay.
And usually you just take like a pipe of wax or paraffin and stuff like that, and then this is burning down with the oxidizer. But 3D printing would give you the possibility to form a pipe and an internal structure that the charge burns down in a specific way. So you, for example, want to have not that high amount of thrust in the beginning, and then the thrust changes again because the internal structure of the burning part is getting different. And this is something where something like that could be really interesting, and also where you can achieve something with 3D printing that was not possible with kind of conventional manufacturing methods. So
yeah, I'm thinking solid fuel thrusters, for example.
Yeah,
right
it's
now.
exactly the same. Yeah. So I think there are, if you look into model rockets, you can get them with different, I don't know, in German we say Seele, soul, like the shape of the internal bore that starts to burn, and that is then changing the thrust pattern of the charge, and that is really interesting. And if you can even do that in a 3-dimensional way, you would be totally free with like thrust patterns for a small rocket that probably doesn't make that much of a sense. But if you're thinking about something different and outside parameters like drag or weight of the rocket and something like that may change, you can directly influence that with a charge that is formed in a specific way.
Yeah. And space, what is it? Space exploration, the entire SpaceX pattern of missions that they're flying now. They've just had their corn silo essentially do the hop the other day. It's like, you look at it, it is really cool. You look into it a bit deeper, and it's this rabbit hole that you can go down, and there's so much interesting stuff to learn there. Yeah, fascinating stuff.
It definitely is. So, yeah, 3D printed metamaterials. All right.
Doesn't need to be gunpowder.
Doesn't need to be gunpowder.
Let's hammer out a few quick ones, I guess.
Yeah.
So there is, okay, where do we start? Germany. You guys know we have a norm for everything. We have a norm for how toilet paper is shaped, for how straight bananas need to be, for whatever. Now we also have a norm for open hardware. So this is DIN spec 30. I just lost the title there. 3105. DIN spec 3105. Which is building on top of the open source hardware definition, more or less, but now it's putting it into an official. Well, DIN isn't really a government body, but like an official norm setting, company, essentially, norm creating company, that's saying, okay, if you adhere to this, then you're adhering to what we would consider open hardware. Mm-hmm. And so typically the way DIN norms work is, even though as an engineer or a designer of parts that are going to be used for a specific purpose, you need to adhere to them. The norms themselves, you have to buy. They're crazy expensive if you don't have like a student access or a library as a student that you can access them. They're like a couple $100 a pop, and if you design a product, you need dozens of those. But DIN spec 3105 is free itself, so it's a, I don't know if it's Creative Commons or something, but it is free to access. And it was also developed in cooperation with actual open source hardware people. And I think it's just such a radical 360-degree move for the DIN company. Mm-hmm. The Deutsches Institut für Normung. Is it right?
Yeah.
I don't know, kind of makes me happy that there is that, like, open source hardware is being recognized. Mm-hmm. By these like old-fashioned traditionalist companies, and it's actually done properly.
Mm-hmm. In what way will this norm help open source in general? So I think how I have read it, it gives you kind of a guideline what things you need to do that you are in the end really open source. I don't know. Is that talking about licenses? Is that talking about which things you need to provide that something is really open source? What you need to provide that somebody else can use your design, modify it, and use it for their own purposes.
Yeah. So I think that's actually one of the things that they really focused on, the fact that it's not just, hey, I'm claiming to be open source, but that they're setting, well, a norm, a standard for what would really be considered an open source hardware design that is actually usable. Like I said, there were people that are actually working in open source hardware design that participated in creating that norm. And yeah, so one of the quotes from the netzpolitik.org article is loosely translated by Martin Heuer, who they interviewed. For mechanical hardware that calls itself open source, only about 10% is really open and well documented in a way where it is usable. So yeah, that norm is really defining and setting standards for that level of, it's not just calling itself open source, but it is actually open source in the intent of it. I guess it's kind of similar to what the Open Source Hardware Association is doing with the Open Source Certified. I don't know what it's called exactly, but that process where they certified, I think, the low spot printers, and who else? There were some other hardware bits that they actually certified. I guess it's very close to that. Whereas the Open Source Hardware Association is going into the company and checking everything. The DIN spec is something that you can work towards as a company, and I'm not sure if it's self-certified or something, but yeah,
that is
just the idea of, here are some things that is going to make open source hardware actually usable instead of just being one more sticker badge.
Yeah. And it is available, and I think only available in English. So it's something not only, well, we Germans can now use. So it can be also a guideline for maybe getting into an ISO norm or SAE, or I don't know who is also kind of taken up that topic and working on it. And I think it is really nice because, yeah, it is hard. I think for if you don't have those guidelines, it might be sometimes hard to really say, okay, this. No, let me put it this way. As you just said it, it is a good tool to not only use open source as for advertising, but if you say, okay, I'm open source per DIN 3105, that also means that somebody else has access to all of the data that is behind that, and basically has all of the information to use this open source hardware, continue working with it, and might not find at some point that 95% of the stuff is actually missing that he would, or he or she would need to have for working on it.
Yeah. The Open Source Hardware Association definition of open source hardware seems to be a bit wishy-washy, a bit loose on what exactly you need to do to be usable. I think that then flashes that out a bit. So yeah, very nice. It would be interesting to see which of the 3D printing companies that claim to be open source actually are open source, according to DIN spec 3105.
Yeah. Have you already looked into the norm?
I don't think I've read it completely, but you can. Oh, you have to PDF download by it from the. Okay. Nah, I will.
Yeah.
I have not.
Gonna be interesting. Cool. Let's talk about more open source, and let's talk about an open source vision-based print correction algorithm.
That just rolls right off the tongue, doesn't it?
Vision-based print correction algorithm.
So, yeah, go ahead.
So, what Joshua Pierce
Dr. Joshua Pierce.
Sorry, Dr. Joshua Pierce and another researcher from the Michigan Technological University have shown is basically a vision-based. Is it AI? I haven't seen that buzzword.
I don't think it is AI. I think that's one of the things I actually looked for in that article.
Well,
So,
it says AI at some point, but I don't know if that was just the writer of the article. But what they're basically doing is they're having a couple of stickers around the print bed to calibrate the camera. They have one camera taking a look at the print itself, and then after each layer, or even during the layers, they are monitoring what material is laid down and then analyzing that structure and making sure that it is the same as it should be, considering the G code. And if that's not the case, they can either tell you, okay, there was a print error during manufacturing, or I think they even want to correct during printing itself. So if you have a layer shift, or I don't know, if something is just not working as it should be under extrusion or stuff like that. And that is really interesting, because quality control and quality assurance is something that is really, really hard in 3D printing. And one of the reasons why 3D printing is still quite a bit away from real serial production.
of course, you can do things like you take a picture of every layer and compare it to what it should be looking, but you're not really going to catch small defects like that. If you just do an A/B comparison, that's like semi-automated. But this seems to be this seems to be exactly that, but better. So okay, it is not AI. It is an extensive set of highly numerical image processing techniques. So I think what really makes a difference from something like the Spaghetti Detective that is a trained AI is the Spaghetti Detective does not have an understanding of how the part should look.
Mm-hmm.
It just looks at, okay, does this look like a good print or like a bad print?
Mm-hmm.
And depending on how exactly your print is shaped, that indicator can kind of veer left or right. Even if the part is going well or going horribly, it might not detect it. So the unique thing about does this have a name yet? The open source computer vision based print correction algorithm is that it really takes into account, don't know if it takes into your G code, but it takes into account how the print should be looking, and compares that to how it is actually looking. And yeah, it's a bit more precise than those existing approaches.
I wouldn't directly say that it's more precise, because I think you probably could do exactly the same, or kind of exactly the same, if you would just like photograph each layer, and that to even maybe a finer resolution. The camera approach from the site that they're using might give you the advantage that you can take some three-dimensional things into consideration as well, so Z direction. And I think they just nicely show what they're capable to do if you use those images and if you use a good numerical approach in order to find printing errors. And as I said before, this is really, really important work if you want to use 3D printing for serial production parts. Just think about the 3D printed bike frame.
Right. Yeah.
What kind of quality assurance are you doing to that bike frame in order to make sure that it don't has a void at some point that you don't see from the outside, and will break at some point? This is definitely going into the same direction of doing in situ monitoring of the print. And it can either tell you in the end, okay, this part is scrapped because that happened, or it can directly say, okay, something happened right here, but I corrected for it, so it still is fine. Again, 3D printed bike frame. If you can't do quality assurance on the whole part, you need to take into consideration higher margin of safety, because you always need to say, okay, there is the possibility that something goes wrong at that direction at that point. So I need to make sure that my bike frame is capable of handling 200% of the load and stuff like that. If you have such a system, you can scale down that factor and save weight in the end and make 3D printing more affordable, or the part more affordable in the end. And just looking at emissions and stuff like that, it's more lightweight, and it's is also maybe a more reliable part in the end. So really cool. Open source. Hopefully we might be able to have something running in, I don't know, Octoprint at some point in the future.
Perhaps.
But yeah, it's just... It might sound like a crazy idea of doing all those calculations in the background, but at some point, I think this will be kind of the norm if you want to do proper 3D printed parts. Because, yeah, as I said, it's quality assurance, and in the end, you can say, okay, everything is good. I can sell the part, I can use the part, I can use less material and stuff like that.
Yeah, but I think for the time being, it's just going to be scrap or no scrap for the part, because the real time, if you consider real time correction, in order to detect that something is wrong visually, it already needs to be going wrong for quite a bit.
Yeah.
I don't think we're at the point yet where you can directly look at the nozzle output and be like, oh yeah, this is like 0.5% too much material, which obviously wouldn't make a difference, but you can't really detect it that finely to where you'd say, okay, I've corrected for it the next layer up, and now my part is fine. No, you still have a bad layer in there. So yeah, but so very interesting stuff. And yeah, Joshua Pierce, Dr. Joshua Pierce. I was like, that name sounds familiar. And if you look him up, he's actually got a Wikipedia article. So no wonder I've heard the name before. And apparently he's been active in the rap community for a long time. I guess, yeah, that's why you would know him. Yeah. Very nice work. Definitely well done. Now let's see it implemented.
Indeed. Cool. Next article.
Yeah, let's get into the ranty topic. I don't know how much we're at an hour. Should we do a topic of the week even? Yeah. Let's or did I say we're gonna have 3 quick topics? That never works.
Never works.
Mighty Buildings, another 3D printed building company. Another claim of, oh, we're faster, better, cheaper. Okay, so Mighty Buildings are a California-based startup. Again, I think. Let me check this out. Yes, so California-based startup that are doing 3D printed buildings again. Some of their claims are, let me point out, they have $30 million worth of venture capital in them. So they kind of have the need to generate headlines and to show progress. So they have buildings that can be printed within 24 hours with a 3D printer. Labor time is 95% less. Cost is 45% less. But then you actually look at the buildings and look at their site, and it's like, oh yeah, this 350 square foot building can be printed for starting at $115,000. Plus a slab, plus appliances, electrical, everything. So that's just the frame of the building, I guess. And it's tiny, and it's like, okay, but what's your value now? Like, if you look at I don't know, Hausfertigbau or all of the prefab homes that you can buy here, for that sort of money, you can get a 1,000 square foot house prefabbed. Yeah. And I'm guessing that's going to be way easier to put electrical and plumbing into than into a hollow core concrete wall. That's literally just a concrete it's a concrete brick essentially that you're printing, unless of course that space for plumbing and stuff is already routed out in the print. But still, insulation, electrical, finishing, all that still needs to be put in. And then if you look at how much is like a 1,000 square foot building, and that starts scratching at the $200,000 mark, plus the slab and prep and all that. So I don't know, what do you see, what do you see in this? Am I missing something, or is this just another overhyped 3D printing building thing?
I don't really know what I should think about that.
Let me give you a bit time to think. So what I'm seeing is the building looks kind of cool. So what they're showing is like, the classic shipping container size, but it's got rounded edges on the end. They've got big windows. So it really looks like a modern building, and it is kitted out nicely. It looks like a really modern way of constructing things. Yeah. But it's tiny and it's expensive, and it's like you if you look at how US houses are built, if you do stick frame, I was surprised that your new roof edition is actually also stick framed. It looks like the way those are built is like you bang together the frame. It takes you a day to build that thing. And then you do the siding and you do interior drywall. That's like another few days. But the basic frame, until that's up, that takes you no time at all. So labor costs are minimal as well. So I'm not really sure what they are comparing that to.
I don't know what they are comparing it to either. It does look more futuristic than a normal drywall house. That's not really a selling argument, but I don't know. I even don't think that it's printed in concrete. If you take a look at their YouTube video that they're having, it looks more like it's a full polymer house.
What?
And that might be one of the reasons why they also say that I don't know if that is that ecological, because you can shred the house down and print another one with it.
I don't know. Well, it depends on the polymer. If you're printing it from ABS, I'm not sure if you want to do that.
Me neither. Well, I think it's at least nice to see that they can show off something, and the video that they're showing looks kind of nice compared to other things where you just like print a wall with a concrete extrusion machine. But comparing it to conventional methods, I don't know if it's really competitive, especially looking at the prices. This is something really futuristic where you could say, okay, such a technology could be used to 3D print houses on another planet or something like that. But as for now, I don't know. I honestly would kind of stay away from a 3D printed house if I can get a wood frame conventional house for like half the price or double the size at the same price.
I mean, if like a 32 square meter, 350 square foot house, I guess that would be just at the edge of what would still be considered a tiny house. And if you look at how much people spend for those, it is a lot less, for sure. Now, what I'm going to say is I would really like to just spend a day talking to one of the folks or one of the companies that are doing 3D printed, well, quote unquote, 3D printed buildings. I hear there are some towards the Netherlands up there. There are a few there that are actually claiming to have printed houses, or if I ever make it to California, I would love to check out what they're actually doing and what is 3D printed, what is not, and what like the total approach to it is.
One correction from my side: they're not printing in polymer. They are using their breakthrough limestone material, which hardens to a stone-like composite. So
it's like a Roman concrete.
Something like that, yeah. So sorry for getting that wrong. Yeah, it's hard. Looking at the design freedom you might get, maybe not even printing a whole house, but just printing like complex segments that you put together into one big house in the end, it might be interesting. Also the possibility to directly include like air pockets on the inside for insulation purposes and stuff like that might be interesting, but the question is always how that compares to a conventional house. But on the other hand, yeah, you maybe you gotta start at some point, and maybe this might be something that could be useful to manufacture houses at a location where not so much wood is available, but you can truck in their limestone 3D printing material, or if you do it on another planet, I don't know.
Yeah. I guess, yeah, this is really one of the things that I would love to see actually work and work out. Yeah, but it's just hard to see what the advantage is, because in let's say you want a house for you, yourself, your wife and a kid maybe, or you want to build something somewhere. This isn't the process that you would really look into, I think, unless you want the edge of you want to be that early adopter that has a 3D printed house.
Honestly, just taking a look at the houses, they do look really nice. If I would have like way too much money and a big property, I think that would kind of look nice in the garden, just having as a home for visitors.
But it's like anything but that swoopy end you can do with a SIG frame.
Yes.
Like literally, there's nothing.
But
that needs to be.
Then you can say, okay, my house is 3D printed. This is one of the only ones there are. If you guys are interested, check out their website, and if you go on Prefab Technology, they show the printing process, the 3D scanning process. They actually fill the voids in the parts with PU foam for insulation, for additional insulation, and then they machine all of the interior and exterior surfaces that you don't see the layer lines anymore, which is also pretty interesting to see. Yeah,
does that?
It's hard to say. As I said, I think they look cool. Not competitive at the moment, but I don't know. There could be applications.
Automated PU foaming, so it's spray foam.
Yeah.
Okay. Okay. Well, like I said, I would be really interested in checking out a real world 3D printed house at some point, and talking to the company, just seeing what I'm missing, because I'm sure there's more to it than than what the flashy website says. Because if you run the numbers, it just makes no sense at all.
Yeah.
Anyways, let's stay on the topic of rant, and maybe let's have a bit of a topic of a week of the week, if we may. Crowdfunding, Kickstarters, Indiegogos, GoFundMe's. Well, GoFundMe's a bit different, but so for me personally, a while ago I made the decision I'm not going to be I'm not going to be covering or reviewing or having or advertising for crowdfunding projects that are not fully delivered to their backers yet. And well, at least for me, my review terms, my review guidelines are up on the website on tom's3d.org. Everyone can look into that, can read through that, and that applies to every review that I do. So last week I got, I think, 3 or 4 emails from different parties being like, hey, we've got this thing coming up on Kickstarter. Can you review? Can we send you one? Do you want to review it? I'm like, guys, read the guidelines. And they're like, yeah, we read them. And then I had to actually copy paste in the section where it says, I'm not going to deal with Kickstarters. And they're like, oh, we missed that. Yeah. And you and I, we were also approached by someone who is planning to do a Kickstarter and wants to do like a revenue share if we advertise that upcoming product. Okay, here's my problem that I have with Kickstarters, and we've briefly gone over this before the podcast, just so we were kind of on the same page. To me, there are 4. Let me actually expand that to 5, because there is a genuinely good Kickstarter project every now and then that is well planned, well executed, is a good product in the end. That can happen. But the 4 different Kickstarter companies, or the initiators of a Kickstarter campaign, not being Kickstarter specific, Indiegogo, just the same, like 4 different ones. 1, good product. No idea about business management, budgeting, all that. Basically, an engineer like myself will go onto Kickstarter and be like, hey, I've got this cool idea, this cool project that I think I can make happen. And then they drive the thing into the ground. They run out of cash. They have to, I don't know, sell the product on retail sites before they can even deliver, because they're kind of trying to get cash in to even deliver their Kickstarter promises. Then 2, the other way around. Really good marketing, really good business sense, good at making money, product that is never going to work. Just from an engineering standpoint, where it's like, oh, we've got this prototype, we managed to build 1, but if you actually have to build 1,500 of them, it doesn't work out. 3, companies that don't need the funding, companies that just use Kickstarter as an advertising platform, and we've seen so many of those recently. And it's not like Kickstarter, it's like you're kickstarting a company off the ground. You give them money so they can actually run at scale. And it's like, if you have a company that has already sold 500,000 printers last month, they have no business on being on Kickstarter. And then 4, what was the 4th one? Yeah, actual scammers. Those exist as well. Like people who just put something out, try to grab a bit of cash, and just run away with it. So between those 4 scenarios, it's like every company that's approaching me to advertise for their Kickstarter, or that they want to send me a review sample, or I don't know, have me push their Kickstarter product, it falls into one of those 4 categories. I've not been approached by one that I think is actually the genuinely, this product belongs on Kickstarter. We've got a good business sense, we've got a good product, and we mean well. I don't think I've gotten one of those, let's say, at least in a long time. So Kickstarters, man.
I feel you, but this really sounds very, very negative in the direction of Kickstarter. And in my opinion, there are a considerable amount of Kickstarters or anything in that direction launched that do have the right purpose, and they need the money to start up the company and stuff like that. But I think those are rarely the ones that approach at least us in the thing that we usually do. And it's the same for me. So for example, I just yesterday declined exactly reviewing a Kickstarter 3D printer that quote is gonna be huge at some point, whatever. And then I said, okay, no, not gonna be doing it. And then I get an email back, okay, we will give you $500. Will you do it now?
Oh yeah, the entire topic of I think that company that sent it out to you was right away like, hey, what are your terms for review? How much do you charge for a review? Can we send you this printer? Like, it's literally on the website. I don't charge for reviews. I pick which products I review, not the company paying me to do it. Sure. Now, just Right. The other thing that's kind of riled me up, and why I've put this topic into the list of topics for this episode is that dude that approached both of us. Okay. There was a suggestion in there basically of a revenue share. So not just, hey, I pay you to advertise for this product, where it's like, you book a 15-second sponsored spot, which is, super common. I'm not going to do it for Kickstarter project, but if I genuinely think it's a good product, and you're very welcome to advertise on the channel. But Kickstarter product, first of all, but also it's not like, yeah, here's X amount of money to do that integration, but if the project performs well, I'm going to give you X percentage of my revenue. And that puts you, as a creator, in a really crappy spot, because now essentially you own equity in that company. You're now a venture capital investor in that company, not by investing your cash, but by investing your airtime on the channel, basically, or advertising budget that you would be able to earn otherwise. And it kind of ruins your neutrality towards that product and its competitors, because even outside of that video, outside of that very limited and sharply defined sponsor spot, you now have a genuine business interest in getting as many people as possible to back that project.
Totally understand.
So, please do not approach me with that sort of stuff.
Totally understandable. But I think this is also, well, this is kind of a negative and maybe too negative view on the approach that we had. I just had the impression that he said, okay, I don't have enough money for a marketing budget, and if you spend your time, I'm happy to share revenue. And I think you can basically take that in two ways. For once, yes, you're definitely invested in the company, and the better you kind of market it in the end, the more gain you have for yourself. But I think it was just more as, I think I have a cool product. I don't have the reach to do that, but I think it's not a scam, and it will be, as I said, something cool in the end. And if you spend your time, I will pay you something afterwards when I have the money from the revenue of the product. This is the way I understood it, and
true. I mean, that's the intent behind it.
That's definitely the intent behind that, and you can definitely take that both ways.
Not the result. Yeah. It's just that the lines get really blurry at that point.
Definitely.
I guess it's the same mentality, because starting from the basic series and upcoming videos are also going to have more sponsored spots, just to help me grow the channel and to find. I mean, I want to do Philween, but I can't do Philween. I need more people for Philween, so I'm going to hire someone else at some point. And it costs money, obviously. But yeah, with sponsor spots and with anything that is like an affiliate program or anything else, like a paid tutorial for Hemera conversion, you really have to be clear about the point that it is that you're allowing the company to advertise on your channel because you think they make a good product, not that you're saying you're making not that you are going to portray the company as making a good product because they pay you. No. So I've had the discussion with my mom recently, who's handling all the sponsor contacts for me. I mean, she works for me part-time. And she was like, well, you got to be careful how you review their product, and because they have already booked and want to continue booking sponsor spots. And I was I don't have to be careful. Like, if they make a crap product, then I will very happily say that, and I will happily yeet them off the channel for sponsorships indefinitely if they really make something that does not work as advertised, or is just a ripoff. Yeah. And with a Kickstarter project, you can't even know that. So something I've got on the website is, let me actually read this off real quick here. Reviews of pre-release products provide limited value to end users. NMTS, that's my company name, will not accept any pre-release hardware for review. Identical conditions apply to crowdfunded products. Due to a history of drastic changes between the campaign and the final release and the recent rise in crowdfunding fraud, we will also not review crowdfunded products that not have yet been completely fulfilled to customers. So that possibility of we have a great prototype that works and that does everything as promised, but the finished product will need to be cost down and feature limited version. That can also happen. Or it's just going to be let's say it's a hot end and they have a really good heat break, but they find a way to machine it more cheaply, to produce it more cheaply, but it doesn't quite work as well anymore. Like, what you going to do there? Unless the thing is shipping, I'm just not gonna deal with it. So, yeah,
that is definitely a very brave decision, and also just shows that you as listeners and viewers always need to pay attention, because there is lots of advertising money flowing into different channels and resulting in reviews and just, I don't know, unboxings, testings, or whatever of products that might not come on the market at all, or might come on the market in a different manner. So just keep that in mind.
Yep.
Good.
Yep. Glad that's off my chest.
All right. So then maybe let's stop ranting and get to the questions, which today is just one question.
Yeah.
So Thomas A88 is asking, question: Have you printed in exotic materials or ordered such prints online? Any specifically thinking about ceramics? I'm thinking about ordering some from Shapeways, but it looks like Shapeways no longer offers that material. Do you think that PLA prints at home would be suitable to indicate model printability, or should I expect to order multiple samples? So he's basically asking if we have experience with ceramics, if we have experience with ordering from one of the Dienstleister,
3D printing services.
3D printing services.
Print to order. Yeah.
And if PLA printing a part at home can indicate, printability with another technology or material. So, yeah. What's your take on that? Have you printed with ceramics before?
No.
How could you print with ceramics?
So, isn't there the lay brick or one of the materials from that guy that is like a washable, or that then kind of transform after the print?
Yes.
I think that's one of the few ways that you could print with an FDM process, with a filament process that does ceramics.
So there are FDM materials that are ceramically filled, and that you then basically either use a solvent to get out the binder, or you just burn out and then sinter together in an oven. There is Formlabs ceramic resin, which uses SLA as a printing process, and then you do basically the same in the end.
You burn off the SLA binder resin, and then
Exactly. I don't know if there's direct laser sintering of ceramics. I wouldn't be aware of that, but I could be wrong, or at least in a commercial way. So
that would be the next question. Like, how does Shapeway do it?
Probably with an SLA process. I would suspect that, because that offers you lots of details and it's, well, you don't have the layer lines as you would see with FDM 3D prints, and the parts themselves usually also look better from what I have seen in the past, but I don't know what they did.
Right. Apparently, there's also a so binder jetting.
Yeah,
you can do.
of course, but also the same thing in the end: burn out the binder and then sinter the part.
Yeah, but it's who's the company that does the gypsum full color print? Now part of someone else. Z Corp.
Okay.
Back in the day, those were binder jetting. No, what was it? Binder? I guess it was binder jetting. Yeah. So technically, those are ceramic prints as well. But yeah, it's mostly, according to this article that I found on All3DP, binder jetting DLP is apparently something that also happens a lot. Yeah. Or of course, if you want to do really coarse stuff, you can do the extrusion process where you have an actual ceramic paste that you extrude, and then you get a solid ceramic part right away.
Of course.
But I don't think that's the approach that Thomas A88 is looking into.
Okay, so next step: have you ever ordered something from a 3D printing service provider?
I have not. I've not had the need, but I've been offered credit for, I think, Shapeways or one of the companies that does that.
Yeah, I think I haven't ordered something either, but yeah, I have the, I would say, opportunity to at least get in touch with metal 3D printing at work, and also with lots of other technologies there. It sometimes is a nice opportunity, especially if you are like developing a product and you don't want to invest in injection molds right away, to order SLS nylon laser sintered parts, right? Because they can look really nice if the surface finish is right at the end, and they can also be really strong. So that could be an opportunity to get one of those parts. But yeah, as I said, I haven't done that either. I actually wanted to do a video. There is one big hardware store in Germany called Tom Baumarkt, and they are also offering a 3D printing service where you can do everything. Sorry. From FDM over SLS over metal 3D printing, using, I think, Materialize as the service provider, or somebody else.
Okay, so it's not them having an array of 3D printers in the store.
No.
It's getting shipped out.
It's getting shipped out, but just ordering a Benchy FDM 3D printed in ABS was like around 100 euros. So I thought, okay, wow, too expensive. Not gonna do that video.
What would you use that for then?
I don't.
Because even for like repairs of household appliances and stuff, for that sort of money, you can buy the thing new.
Yeah, there were.
Okay.
They advertised it quite a bit at our hardware store, and I thought, yeah, why not try it out? Might make an interesting video, but I didn't want to invest that amount of money because, yeah. Well, yeah.
I mean, usually when you have our sort of reach, you reach out to the press department. They're like, yeah, sure, we're gonna ship you anything you want.
Yeah,
that's usually. But anyways, if it's not like I said, if it's not a good product, then why cover?
Yeah. So there are services available from Shapeways to any other ones. I haven't used them so far, so maybe let's get to the third part of the question. Do you think that PLA test prints would show a suitability for model printability? To some extent, definitely yes. And I can also say from my experience that if you have a metal 3D printed part, so direct metal laser sintering, just FDM 3D printing those parts at first already gives you a really good indication if the part is printable or not, to some extent, considering overhangs and things like that. Where the FDM print usually looks horrible, the metal part won't work at all, or it would also look horrible. Yeah. But depending on the technology, there are different design rules, so it doesn't work for every technology.
True, but it is surprisingly similar
Mm.
how the limitations align between, even between SLM, FDM, SLA. They all kind of have that same, you have a minimum wall thickness, you have certain geometries that don't work because they're going to warp, you have overhangs that are not going to work. So yeah, it's going to give you a rough idea if it's going to work, but just looking at resolution, if you're ordering like specialty stuff, ceramics, you probably got like a high detail part, I'd guess. So maybe scale up your PLA test print, by a factor of 2 something. But in general, just because it's so different on the fine detail and resolution side, I don't think it's going to give you much of an indicator of if it's going to work. But I mean, if it's going to work in PLA, it's probably going to work on a finer ceramic SLA or binder jetting process better.
Maybe,
I'd guess.
Yeah, I think at least it doesn't harm. And I often see that if people just don't have that much experience with 3D printing in general, 3D printing a part out with a cheap process like FDM already gives you a good indication what can be 3D printed and not. And then you can just take a look at different design limitations of other processes, be it minimum, maximum wall thickness, maybe even print a part in ABS or something that is a little bit more, harder to print, because that could indicate earlier that something is not working, because with PLA you can basically print almost anything even without support structure. So maybe use ABS
overhangs and stuff. Yeah, for sure.
Yeah.
All right.
So maybe even the fourth or the last part of this question, should he expect multiple samples depending on the complexity of the part? I would always suggest to expect an iteration.
Yeah.
If you haven't used the technology for a couple of times. Yep.
For sure. But the test printing with PLA is going to give you probably a better, and if you tune that print to print well on, or the part to print well on an FDM process, you're probably going to get a better starting point for tuning it once you start going into your actual process.
Exactly. Cool.
I hope that answered that. Oh,
right.
Headphones are actually still comfortable today. Got the Biodynamics DT770.
Cool.
Same ones I use on the regular one, just with a close back.
Yeah.
Really like the fit of these. So
still like my Bose QC25s, but it is nice having a comfortable pair of headphones. So, all right.
Absolutely.
Cool.
So we done?
Yeah, I think we're done. Thanks for your time, Tom. Thanks for you listening.
Thanks for finding the time, Stefan, in these busy times for you.
Yeah, I'm always saying that I hope next time it's going to be at a more regular interval, but we'll see. Times are changing.
I feel like it's my turn to get this more efficient process done for recording this, because right now we're still sending files back and forth. We got 2 audio tracks, 2 camera tracks. We have to sync them all together, edit them, and then I'm working on it.
We should get a podcast editor, but YouTube revenue, I think, would not even pay for that.
I don't think so. Nah. We need sponsors on the podcast.
Yeah. Oh, I've just seen your video has gone online 32 minutes ago.
Oh yeah. Oh, I need to publish the Prusa Printers site as well, because that's linked in the video.
Cool. All right. So
I'm gonna get to that right now.
Do that.
So,
and
thank you all for listening, watching, staying through the 1.5 hour episode. Thank you, Stefan, for taking the time.
You're welcome. And we're gonna see you next time. Bye. ASMR. Let's do a sync clap.